Hello, now we'll move to Applications on Geometric Sequence, Part 2. We are given a sequence un defined by un equals 3 to the exponent n over 2 for any natural number n. Question number 1. Prove that un is not an arithmetic sequence. How to prove that a sequence is not arithmetic? Because they told us that it's not arithmetic, then it's enough to find three consecutive terms of this arithmetic sequence and prove that there is no common difference between these terms. So for example, let's calculate u0, u1 and u2. To calculate u0, it's enough to replace n by 0. u0 equal 3 to the 0 over 2, which is 1 over 2. To calculate u1, it's 3 to the exponent 1 over 2, which is 3 over 2. And to calculate u2, it's 3 squared over 2, then it is 9 over 2. Now to prove that sequence is not arithmetic, we have to prove that u1 minus u0 is not equal to u2 minus u1. What is u1 minus u0? 3 over 2 minus 1 over 2. It's 2 over 2, which is 1. What is u2 minus u1? 9 over 2 minus 3 over 2 is 6 over 2, which is equal to 3. The difference between the terms u1 and u0 is not equal to the difference between the terms u2 and u1, then the sequence is not arithmetic. Now in the second part, for the same sequence un, we are asked, is this sequence geometric or not? We already calculated u0, we calculated u1, and we calculated u2. If we're thinking of calculating the ratios between the terms, okay, we'll calculate u1 over u0, we'll have 3. We will calculate u2 over u1, and also we'll have 3. Since we are having the same ratio, this is not a confirmation that this is a geometric sequence, because it looks like that it is geometric, but it may not be at a term later on, for example, the 100th term, etc. So, in order to prove that it is geometric, we have to prove it in the general case. So, we know that un is equal to 3 to the n over 2. We have to calculate un plus 1 in terms of n. Then, find the ratio of un plus 1 over un and prove that this ratio is independent of n. It means that this ratio is a constant for any value of n. un plus 1 is 3 to the n plus 1 over 2. We just replace n by n plus 1. Now, if we calculate un plus 1 over un, we will be having 3 to the n plus 1 over 2 divided by 3 to the n over 2. Now to have the division of quotient, we take the numerator and we multiply by the reciprocal of the denominator. So the answer is 3 to the n plus 1 over 3 to the n. Here we apply the property of simplification of fraction with exponents, so we have to subtract the exponents. And the answer is 3 to the exponent n plus 1 minus n, which is 3 to the 1 equal to 3. Now, the quotient of u to the n plus 1 over u to the n for any value of n is a constant ratio. Now, since the ratio is constant, which is equal to 3, then the sequence is geometric with common ratio 3, and first term u0 is equal to u to the 0 is equal to 3 to the 0 over 2, which is half. Now to conclude, to prove that a sequence is geometric, we have to prove or to calculate that the ratio of u to the n plus 1 over u to the n, in general case, I mean that the ratio of any two consecutive terms in terms of n is a constant independent of n. Thank you.